Hello, good day, viewers. You're welcome back. In this virtual class, we're going to look at the derivative of inverse function. Here, we're going to look at sec inverse. Y is equals to sec inverse of x over a. Here, what we do first here is, if we recall that if we have a let's say d raised to the power minus 1 is the same thing as 1 over d. So we use this fact, to create or to express this. So we can say that y here is equals to x over a divided by sec. Okay. Our interest here, first and foremost, will make x the subject of the relation, or then we also express sec as a function of x. Okay, we multiply both sides by sec, so sec times y, that will become sec y. Here, if I have sec over a divided by sec times sec, you see that the sec will be off, and we will have here that sec y is equals to x over a. So this is equation 1 of x. We also look at another fact to make x subject of the relation. If I'm making x subject of the relation, we multiply both sides by a. This becomes a times sec y. That will give us a sec y. Here we go a times x over a will be off, and here we see that x is equals to a sec y. This is equation 2. From here, from equation 1, we will establish a fact here that sec is 1 over cos. So this expression is saying that 1 over cos y is equals to x over a. If we cross multiply, or we want to obtain just cos y as a function of this s and y, here if we say inverse, this will turn, cos y will be at the numerator, y1 will be at the denominator. Similarly, this will be at the numerator and this will become the denominator. So here we say cos y is equals to a over x. Okay, from this, so this is another equation. Now let's go to our right angle triangle and establish this fact. Okay, so here this is a b c. Cos, this is our angle, for instance. Put an angle here. Cos, which is is adjacent over hypotenuse. Adjacent. The ratio of the adjacent, which is a over what? Over the hypotenuse. So the hypotenuse is x, your adjacent is a. Then we need to obtain an expression for this using Pythagoras theorem. So if we do that, we see that AB is line AB, it will be square root of AC square, which is S square, minus BC square, which is A square. So this part, this expression AB is S square minus A square. And if you look at the other expression we have been doing with those cos and the rest of them, you see that it is A that will come first before S square. So, but the thing has changed. Here we have done with that. All we need to do here next is to look at equation 2. Let's now find the derivative of this equation 2. Let's look for the x. This is the x over the y. If we differentiate sec, our resulting answer will become sec y tan y. Okay, we can go and verify that the derivative of sec is sec tan sec times tan. Okay, and here we also know that sec y has an expression which is x over a. So we come here, this is the x over the y. This is a times x over a, because the expression for sec is x over a. Then let's look at tan. Tan is opposite over what? Opposite over adjacent, which is root s square minus a square. That is the opposite. Then our adjacent is just a. Okay. What's next here? A can go with a first, though we still have another a here. All we need to do here is let's write this clearly here. The x over the y is equals to x over a root s square minus a square. But we are looking for the y dx. So if we are looking for the y dx, what will eventually happen if we are writing this as the y over the x, this become a over x root s square minus a square. So the derivative of sec inverse of x over a is just a divide x into s square minus a square. This is the derivative. For instance, let's look at this. Imagine we are having a function of y is equals to sec inverse of x over 3. So I'm asked to find the derivative, first derivative. Here our answer will just become, what we have here is 3. We'll put 3 here, divide, here we have x, the square root of s square. If we square 3 minus what? Minus 9. It's as simple as that. So this is how to derive the proof for sec inverse of tan or sec square x. Okay, in our next lecture class, we'll look at that of cots as well as that of cosec. Have a nice time. See you in my next virtual class.